Welcome back to Aurora Tech Channel. Today, I will review the Prusa MK4S. I reviewed the Mark IV last year, and while it was a good printer, I wasn't too excited about it at first. However, after a few firmware updates, its performance improved by a lot. Eventually, it became my most used printer and earns its permanent spot on the rack in my garage. Recently, Prusa launched an upgraded version, the Mark IV-S, which looks similar to the Mark IV, but includes two important upgrades along with some new minor features. Fast printing requires four key factors: a good motion system that allows the printhead to travel quickly, firmware support for input shaping to maintain surface quality despite vibrations and movement at high speeds, effective part cooling to solidify the filament faster, and finally, a high-flow hot end to melt the filament quickly enough to keep up with those speeds. The original Mark IV already had thicker linear rods, which I consider a good motion system. Since firmware version 5, the Mark IV also supports input shaping, and the latest version is actually 6.13, so the firmware aspect is covered. However, the Mark IV's cooling fan is a bit small and only blows from one side, which isn't ideal for cooling when printing at high speeds. Additionally, the standard nozzle may not melt filament fast enough to keep pace. The two major upgrades in the Mark IV-S are the CHT high-flow nozzle and a more powerful part cooling system with a redesigned fan duct. With these two upgrades, all four key factors for high-speed printing are now included. Other features include an NFC module, which allows you to transfer Wi-Fi settings from your phone to the printer with a single tap, and a new mobile app for managing multiple printers. Many parts have also been replaced with PC carbon fiber and injection molded parts, giving the machine a more premium look and making the parts more durable. The Mark IV-S also offers an optional accelerometer for input shaper calibration if you're not satisfied with the preset values. Additionally, there's a GPIO extension board that lets you use G-code to send digital signals to another microcontroller or receive external signals. This opens up many possibilities. In addition to the Mark IV-S, I will also be testing the MMU3 multi-filament system to see how it compares to other options on the market. I would like to thank Prusa for sending us these machines to review, and I would also like to thank VOXELPLA for sponsoring today's video. VOXELPLA is a brand created by a print farm in Southern California, where they exclusively use their own filament with over 150 3D printers that are operated 24/7 non-stop. This extensive testing leads to high quality and reliability in their filaments. VOXELPLA Pro is a modified version of PLA that provides higher impact strength and supports high-speed printing of up to 500 mm per second while maintaining a flow rate of up to 25 mm3 per second at a regular printing temperature of 210 degrees Celsius. VOXELPLA Pro is also affordable at just $16.99 for a 1 kilogram roll. Ordering 3 rolls comes with free shipping, and bulk discounts are available starting from 6 rolls. They have recently launched new filament colors and other accessories for Prusa and BambuLab printers. For more information, please visit voxelpla.com. The fully assembled printer came in one box, protected by laser-cut foam and cardboard. Accessories were packed inside another box, along with a new roll of filament. Here's everything we received: the MK4S printer, a spool holder, a filament guide, a power cord, a USB drive, some tools, a user manual, and my favorite, the gummy bears. It came with a smooth PEI sheet, and there was a simple test print on the bed showing that Prusa tested every single fully assembled machine before shipping. Before we start using the printer, we still need to snap the filament holder onto the top. A filament guide is mounted between the spool and the extruder. Once that's done, we can turn on the machine. A setup wizard appears, starting with language selection. Next, it shows the screen to confirm if the configuration matches your printer hardware. I didn't need to change anything here. Then, it tells you to set up Wi-Fi using your mobile app. I followed the on-screen instructions on my phone. I selected the model of the printer, entered the SSID and password of my network, and then used the option to transfer this information to the printer via NFC, similar to using Apple Pay. On the printer screen, it shows that the network information has been received. After a few seconds, it successfully connects. Next, it asks if you want to use Prusa Connect, a cloud-based service to manage multiple printers, control individual printers, and store files on their cloud server. This is optional. If you prefer to keep all your files within your local network, you can skip it. I decided to set it up. A QR code appears, and if you already have an account, you can scan it with your phone to add the machine to your account. Okay, I can now see the MK4S in my account, and the printer screen confirms the registration. The printer then starts the calibration and self-test, beginning with the fans, followed by testing the X, Y, and Z axes. It then asks you to tap the nozzle to test the load cell sensor. Since the nozzle isn't heated, you can use your finger or another object to tap it. It then tests the heating elements in the hot end and the bed. Gearbox calibration isn't necessary for a fully assembled machine, so I skipped that step. Finally, the filament sensor is tested. There was a small piece of filament inside, left from the test print, so I selected Unload first. After choosing PLA, the printer heated up to the preset temperature. Once the filament was unloaded, it prompted me to reinsert it. The sensor responded, and after a few seconds, it asked me to remove the filament again. The calibration is now complete, and we can start our first print. I decided to reprint the quick keychain test print to ensure everything was functioning properly. After reaching the target temperature, the printer performed quick checks on the X and Y axes, cleaned the nozzle at the front left of the bed, and conducted small area bed leveling to match the print size. Once it increased the temperature from 170 degrees Celsius to the required printing temperature, the print began. Due to the large part cooling fan and its surrounding duct, filming the nozzle in action was challenging. The print finished in 12.5 minutes, including prep time. Everything seems to be working normally, and this print closely matches the factory test print. Next, I ran another test print, a plate without supports. I think Prusa uses this print to show the strength of its part cooling. The print took 3.5 hours, and as you can see, the overhanging is printed very well without any support. After that, I printed a fast Benchy. It was a preloaded 14-minute Benchy G-code file from the USB drive. I also plan to use this print profile for other models later, but I started with this fast Benchy. The bulky cooling fan and duct made filming the first layer difficult, especially with small models. After a few layers, I tested the sound. With the sound meter about 6 inches away, the noise level stayed around 50 decibels, about 10 decibels quieter than the average open frame machine. During rapid movements, it increased by 1 or 2 decibels. Including prep time, the print finished in under 17 minutes, with the actual print time around 14 minutes. The layers and surface quality were satisfactory, and the cooling performance at the front looked good. The high flow nozzle and stronger part cooling of the MK4S were clearly superior to the older MK4. To compare, I will run the exact same G-code file on my MK4, which is housed in a Prusa enclosure and is one of our regularly used machines. I have a cheap security camera inside the printer, and I use it to monitor the prints. The print started at 39 minutes 30 seconds and finished at 53 minutes 36 seconds, taking exactly 14 minutes and 6 seconds. Comparing the two prints side by side, both look good, but the MK4 showed a tiny bit of stringing, and its cooling struggled at high speeds, resulting in some under-extrusion in certain areas. Next, I will start my benchmark test prints, starting with the number slider clearance test. The print finished in 3 hours, which is slightly slower than the average 2.5 to 2 hours and 45 minutes on other new clipper machines. The top looks nice, the bottom stuck well to the bed, and all the tiles can move freely. Then, I printed the mini honeycomb box to test the extruder's retraction. Surprisingly, this print finished in just 2 hours and 4 minutes, which is in line with or slightly faster than the average 2 hours and 15 minutes to 2.5 hours. I checked the default speed profile in the slicer. The maximum speed is set to 250 mm per second, similar to other clipper machines, but the acceleration is only set to 4,000 mm per second squared, which is slower than average clipper machines. However, since the honeycomb box is small, slower acceleration doesn't impact the actual print speed. The print quality is very good. All honeycomb patterns are printed successfully with 0 stringing. Comparing it to other printers, I think that MK4S outperforms the Creality K1C and Chitu X Max 3. It's slightly better than the BambuLab A1, and it's on par with the BambuLab X1 Carbon and Prusa XL. Next, I printed my own geometric model to test the tolerance and see if the parts can fit together well. I added 0 and negative 0.05 tolerance, so these two should not fit unless the printer under-extrudes. The print finished in 2 hours and 31 minutes, which is in line with other clipper machines. On the square side, it cleared up to 0.05 mm, which is a perfect score. At 0 tolerance, it didn't clear. On the cylinder side, it also cleared up to 0.05 mm and didn't clear at 0 mm. So, similar to the MK4, the MK4S achieved a perfect score on this tolerance test. I then used the 14-minute benchy profile, which speeds up almost everything to 300 mm per second. The acceleration was increased to 7,000 mm per second squared, and the volumetric speed was set to 30 mm cubed per second. I used this profile to print the tolerance test again to see what kind of accuracy it could achieve at higher speeds. This time, the print finished in just 1 hour and 10 minutes, more than doubling the speed of the standard profile, which took 2 hours and 31 minutes. While the surface quality wasn't as good as before, the tolerance remained perfect, clearing up to 0.05 mm and stopping at 0 mm on both the square and cylinder sides. The ghosting on the text was more noticeable, but high speed didn't impact the tolerance results at all. Next, I tested the surface quality by printing the Robo Alpaka model using different profiles and speeds. I started with the 14-minute benchy profile to see if it could deliver acceptable surface quality. This profile printed the model in 2 hours and 13 minutes. It was printed at a 0.25 mm layer height, but it was still very fast considering this model normally takes 4 to 5 hours on other machines when printing at a 0.2 mm layer height. Then, I used the standard speed profile in the slicer to print at a 0.2 mm layer height. This model took a little over 5 hours to finish, which is slightly slower than the average 4.5 to 5 hour print time on other clipper machines. Finally, I used the slowest profile, the original MK4 without input shaping. Sometimes The goal isn't speed, but is instead the best quality, so I wanted to see the difference when using the slowest profile. This print took 7 hours and 36 minutes, 3 times longer than the 14-minute Benchy profile. Now let's compare them side by side. On the left is the 7-hour and 36-minute print, which has the best surface quality. The middle one, printed with the standard fast profile, shows some quality decrease, but it's still acceptable. Surprisingly, the 2-hour 13-minute print is still not too bad. Let's try some different materials, starting with PETG. I'll switch to a textured PEI sheet, which is my favorite print surface for PETG. I will start with Prusa Mint Orange and print a large trash can. There's a small imperfection at the center, but I'll let it finish. I printed 3 walls and 3 bottoms, and it finished in 6 hours and 24 minutes. Since this isn't a tall gantry bed slinger, the surface quality of the top is not too different from the bottom. While there's still some imperfection at the center, the rest of the first layer looks good, and the inside of the trash can has no issues. I'll print another part using VOXELPETG Plus, my go-to clear PETG. This print finished in 3 hours and 30 minutes, and it turned out perfectly. The surface is clean, the bottom adhered well to the textured sheet, and there's no stringing inside. Next, I'll print an ABS crate. The nighttime temperature in my garage is about 25 degrees Celsius, which is a bit challenging for an open frame printer. I'll switch back to the smooth PEI sheet and apply some glue to the bed. There's minimal warping, though the ABS still shrinks and almost cracks in some spots. I turned off cooling to prevent more cracking, which affects the overhanging areas. However, the result is not bad for an open frame printer. When printing ABS or ASA, I usually use the enclosed MK4. Once the print starts, the internal temperature increases by about 10 degrees Celsius, and after an hour, it can reach around 40 degrees Celsius. This allows for good results with ABS or ASA. Then, I printed a TPU tire using FlexLit G40D, which is slightly more flexible than standard TPU. Prusa Slicer has a profile for it, so I used it without making any changes. The print finished in 32 minutes, and the result was excellent, even though the spool had been open for a few months. I dried it when I tested the Chitu Plus 4 2 weeks ago, but didn't dry it again for the MK4S test. Still, the MK4S produced a much better result. As I planned to test the MMU3 multi-filament system, I needed to reprint one of the mounts for the MMU because it was broken. I used nylon carbon fiber for this, switching to a print surface specifically designed for nylon. The first layer stuck well, even without applying glue. The print finished in 1 hour and 36 minutes, and the PACF part turned out beautifully with no issues. Compared to the PETG mount, the PACF version looks much better and fits nicely on the MMU3. Before testing the MMU3, I printed a single layer PLA sheet to check the bed leveling and first layer. It seemed the nozzle was a bit too low. Normally, you can adjust the Z offset in real time. In this case, raising it by 0.02 to 0.03 millimeters would have been ideal. However, I left it to print with the auto Z offset value. The result was alright but not perfect, as the nozzle was slightly too low, causing some imperfections. Still, the sheet peeled off the bed without line separation. It's not flawless, but it should be fine for most prints. Okay, I will now install the MMU3 and test it out. This is a fully assembled unit which costs $359. If you want to save $60, you can order the kit version. If you enjoy assembling it yourself, Prusa has detailed instructions like all their other products, but it may take a few hours to put it together. Since the MK4S comes with a high-flow nozzle by default, I'll swap it out for the standard nozzle. It's not that the high-flow nozzle can't work with the MMU3, but it would require purging more filament when changing colors. In multicolor printing, the time spent changing filament can sometimes be longer than the actual printing time, so the regular nozzle should be more efficient for me. Even with the fully assembled version, you'll still need to set up the buffer and some spool holders, but these are pretty straightforward. You just need to use the provided plastic sheets to form a buffer, which looks like a binder, then install the disc-shaped loaders and simple spool holders. After that, you can connect the Bowden tubes from the spools to the buffer, and then from the buffer to the MMU3. Without any modifications, the setup requires around 37 inches or 95 centimeters of table space. There are modification plans available online. Some users place the spool on top of the machine, some hang them on the wall, and others mount them to the side of a cabinet. I'll load all the colors and switch between them to ensure everything works properly. Then, I'll redo the keychain test print to confirm I didn't make any mistakes. Everything is still working, so I'll print a simple 5-color test from the USB drive. The 5-color ring was successful. All 5 colors loaded and unloaded multiple times without any issues. The filament wasted on the prime tower during color changes was about 6 grams. Next, I'll use Prusa Slicer to slice my own model, the same Hello Kitty that I've printed on other multiple filament systems. This model needs 4 colors. The print time is about 7 hours, and the prime tower waste is about 60 grams, which matches the weight of the model itself. I'll keep the support material the same color to avoid excessive filament changes. When printing light and dark colors together, the default purging volume may not be enough, especially when switching from red to white to yellow, which requires more purging. For now, I'll stick with the default settings and adjust the numbers after the first print. As expected, the red to white color change required more purging than the default settings allowed, but for dark colors, 65 grams worked well and minimized filament waste. The red to yellow transition wasn't ideal. Let's weigh the wasted filament. The model used 54 grams, and the prime tower used 49 grams. This is a pretty good waste amount compared to systems like the BambuLab AMS or Anycubic, which can waste 4 to 5 times more filament, sometimes over 200 grams for the same model. I will now increase the purge value to 150 when switching from red or black to yellow or white. This should waste about 13 grams more filament than with the default settings. The print took 7 hours and 40 minutes, 14 minutes longer than the previous print due to the extra purging. The kitty weighed the same 53 grams, while the prime tower increased to 63 grams, which is 14 grams more. Comparing the two prints side by side, I still notice a slight red tint on the head. However, the red to yellow color change looks fine. To fine-tune the purge value, I printed just the top part of the head and found the perfect result with a purge value of 250. I'm now confident with these numbers, so I will print 4 kitties at once. The print took 15 hours and 13 minutes, about double the time of printing a single kitty, but it was printing 4 at once. Each kitty still weighs 53 grams, while the prime tower increased to 85 grams, meaning each kitty wasted only 21 grams of filament, which isn't bad. Comparing them side by side, I found that the red to white color change requires at least a 250 purge value for a clean print, while red to yellow needs 200. I also compared the prime towers. If I print 6 Hello Kitties at once, the filament waste would be even less. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The CHT high flow nozzle comes by default and can achieve a true flow rate of 30 mm³ per second. This makes it unlike many other machines that claim to reach even higher numbers but struggle to perform as well as advertised when pushed to their limit. The robust cooling system complements the high flow rate, resulting in faster print speeds while still keeping reasonable surface quality and excellent accuracy. 2. When the Mark IV was first launched, it was a good machine, but it wasn't my favorite. However, as Prusa continued to release firmware updates, the machine really improved. While features like the Wi-Fi setup are somewhat outdated, its reliability still allowed it to become my most used printer. The new Mark IV-S is even better, featuring updated capabilities such as NFC for Wi-Fi setup and cloud configuration, making it more modern and user-friendly. 3. There are more injection molded parts and PCCF components replacing PETG parts, which not only enhance the overall premium appearance of the machine, but also speed up the manufacturing cycle. 4. It's quiet. It's not only one of the quietest machines, it's the quietest open frame machine I've tested so far. Even when printing at top speeds, it stays at around 50 decibels. 5. Prusa Connect is a free, feature-rich cloud service that allows you to manage multiple printers and assign print jobs with just a few clicks. In addition to the web interface, the mobile app works seamlessly, enabling you to select models from printable.com and quickly send them to your machine for impressive results. Unlike mobile apps from other manufacturers, it has no advertisements, promotions, or irrelevant events. It just allows you to print and manage your printers efficiently. 6. With the MMU3 multiple filament system, filament waste is minimized compared to the BambuLab AMS and other systems. It also prints much faster, as other systems cut off the filament, leaving a certain length of the previous color inside the nozzle. This requires flushing the nozzle with a significant amount of filament, resulting in a lot of filament poop, and it takes more time for filament changes. In contrast, the MMU3 pulls out the previous filament completely, which avoids this issue. It also works reliably. Throughout the entire testing process, it didn't jam or cause a single error, which is very impressive. 7. Prusa also supports previous models. They still provide firmware updates for the Mark III and even the Mark II. If you want to, you can upgrade your 5-year-olds or even older machines to the latest versions. This is very unlike other manufacturers that launch new models every quarter and leave old models unsupported, so I really appreciate the long-term support from Prusa. I will be making another video to test their Mark 3.5 and 3.9 upgrade kits in the coming months. Now for the cons. 1. The Mark IV-S still uses its own version of Marlin-based firmware. While it has added input shaping and can print at high speeds of 250 to 300 millimeters per second, the surface quality is still just on par or slightly better than many budget bed slingers, but Core XY machines can outperform it. 2. The printer itself doesn't support adding a camera. When using Prusa Connect, you can use an old smartphone, or if you prefer a webcam, you will need a Raspberry Pi to send live videos to Prusa Connect. However, it would be much better to simply plug in a Logitech or standard webcam to this printer, similar to how it works with Clipper. The reason for this limitation is the single MCU that runs the entire system. It uses a higher performing MCU than other regular 32-bit boards, but after adding input shaping, the single MCU may lack the resources to handle the additional load from a webcam. I suggest that Prusa should consider adding a second MCU dedicated solely to handling the camera. Mounting an old phone with a charger to monitor prints doesn't seem like a long-term solution. Additionally, using a Raspberry Pi to control the webcam adds extra costs and just isn't an ideal solution. 3. The footprint and space required for the MMU3 is substantial. If you only have 1 or 2 printers, or you have a lot of space, it may not be that big of a deal. However, with more compact options available, like those from BambuLab, Anycubic, Creality, and other similar one-piece multiple filament solutions that are coming, I believe Prusa needs to redevelop their MMU into a more compact design that packs everything into one box. 4. The MMU3 outperforms other multiple filament systems in terms of print speed and filament waste. However, the filament loading process can be frustrating. You have to cut all the filament tips as instructed, then you still need to push them through the long Bowden tubes and fit it inside the buffer to make sure they load successfully before starting a print. Once you're familiar with this process, it may only take an extra 5 to 10 minutes to load all the colors. Still, I would prefer a one-push system that can load everything in seconds. The MMU3 has big advantages in filament waste and print speed, but it really doesn't need such an inconvenient loading process. In conclusion, I'm very happy with the Mark IV-S. Like the Mark IV, it'll be my go-to printer due to its high reliability and convenient workflow. Prusa Connect, along with the new mobile app, offers the best networking printing and management solution available for free with their printers. If you prefer to keep your files strictly within your local network, you can use Prusa Link to send files directly from Prusa Slicer to the printer, and there's also a simple web interface for controlling the machine. With the new high-flow nozzle and strong cooling system, it can keep pace with all Clipper machines and can even print faster while maintaining good accuracy. Since I mainly print functional parts, the Mark IVS will definitely be my go-to machine. The MMU3 performs well, saving a lot of filament and printing much faster than other multiple filament systems. However, its major drawbacks include the filament loading process and large footprint, which could be deal breakers. If it were designed as a compact unit that packs everything together with a more simple filament loading process, I would consider it to be the #1 multiple filament system on the market, and I would be more than happy to pay an extra $100 or even $200 for it, given the savings on filament cost and time in the long term. However, I will award this Mark IVS the title of the best performing 3D printer on my recommendation list at AuroraTechChannel.com due to its smooth workflow, networking features, reliability, and accuracy. I truly enjoyed the Prusa printing experience, and as you can see, I made a lot more test prints than other machines with this Mark IVS. I also recently updated the layout of my website to help buyers more easily spot great deals. If you're interested in my recommendation list and the hourly updated price tracker that monitors over 150 popular 3D printers, laser engravers, and CNC machines, please check out my website for more details. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.